So now let's solve one more question. Discuss the continuity of the following function. And the first function is f of x is equal to sin of x plus cos x. And second function is f of x is equal to sin of x minus cos of x. And the third function is f of x is equal to sin of x into cos of x. And now let's solve the first part. Now here f of x is equal to sin of x plus cos of x. And in the previous episodes, we have already proved that the function sin x and the function cos x are continuous function. And you already know that if f and g are two continuous function, then their sum f plus g is also a continuous function. So that means the function sin x plus cos x is also a continuous function. In the same manner, in second part, this sin x minus cos x. Here again, since sin x and cos x are continuous function, and as per the theorem regarding algebra of continuous function, if two functions are continuous function, then their difference is also a continuous function. So sin x minus cos x is also a continuous function. And in the third part, f of x is equal to sin of x into cos of x. Now again, if f and g are two continuous functions, then their product is also a continuous function. And in this case, because sin x and cos x are two continuous functions, which means sin x into cos x is also a continuous function. Now let's solve one more question. Find all the points of discontinuity of f defined by f of x is equal to modulus of x minus modulus of x plus 1. Now we already know that the function modulus x is a continuous function, and also the function modulus of x plus 1 is also a continuous function. And as per the theorem on algebra of continuous function, if f and g are two continuous function, then their difference is also a continuous function. So that means the function f of x equal to modulus of x minus modulus of x plus 1 is also a continuous function, which means there is no point of discontinuity of function f. Now let's solve one more question. Determine the value of the constant m so that the function f of x equal to m into x square minus 2x if x is less than 0, and f of x is equal to cos x if x is greater than or equal to 0 is continuous. Now the domain of the function can be divided into three ranges. First, when x is less than 0, and second, when x is equal to 0, and third, when x is greater than 0. And in the first case, if x is less than 0, then f of x is equal to m into x square minus 2x. Now m is a constant and m into x square minus 2x is a polynomial function, and every polynomial function is continuous in its domain. So that means f of x is a continuous function for x less than 0. And also if x is greater than 0, then in that case f of x is equal to cos of x, and which is also a continuous function in its domain. Now let's consider the other case where x is equal to 0. And now what's the value of the function at the point 0? Now f of 0 is equal to cos of 0 or 1. And now this function will be continuous at the point x equal to 0 if its limit is also equal to 1. Now for that, let's first find out its left hand limit and right hand limit. Now left hand limit of this function at x equal to 0 is equal to limit x approaches 0 from the left hand side f of x, and which is equal to limit x approaches 0 m into x square minus 2x. And now x approaches 0, then x will be equal to very small number, so it will be equal to 0 minus 0, again 0. So limit will also be equal to 0 for any value of m, and the right hand limit is equal to limit x approaches 0 from the right hand side f of x, and which is equal to, and now the value of the function when x is greater than 0 is cos of x. So this limit is equal to limit x approaches 0 cos of x, and which is equal to, and now when x approaches 0, then cos x is equal to 1. So here you can see left hand limit is equal to 0 and the right hand limit is equal to 1. So that means the left hand limit and right hand limit are not equal for all values of m. So that means this function cannot be made continuous for any value of m. Or in other words, we can also say there is no value of m for which the given function f of x is a continuous function. Now let's solve one more question. Determine the value of k for which the following function is continuous at x equal to 3. And the function is f of x is equal to x square minus 9 upon x minus 3 when x is not equal to 3, and f of x is equal to k when x is equal to 3. And now for the given function f of x, we are given that the function f of x is continuous at the point x equal to 3. And now because it is continuous, then that means the limit at the point x equal to 3 is equal to the value of the function f of x at the point x equal to 3. Or in other words, limit x approaches 3, f of x is equal to f of 3, and f of 3 is equal to k. So we can also write limit x approaches 3, f of x is equal to k. And what is the value of f of x? Now, as per the definition of this function, if x is not equal to 3, then in that case f of x is equal to x square minus 9 upon x minus 3. So now this limit can be also written as limit x approaches 3, x square minus 9 upon x minus 3 is equal to k. Now x square minus 9 can be also written as x square minus 3 square. And now a square minus b square is equal to a minus p into a plus p. So this equation can be also written as limit x approaches 3, x minus 3 into x plus 3 divided by x minus 3 is equal to k. Now cancelling out x minus 3 from numerator and denominator, then this equation reduces to limit x approaches 3, x plus 3 is equal to k. And when x approaches 3, then x plus 3 is equal to 6. So we can also write 6 is equal to k, or k is equal to 6. So that means the value of k for which the given function f of x defined as xk minus 9 upon x minus 3 when x is not equal to 3 and equal to k when x is equal to 3 is a continuous function is k equal to 6.